Assalamu alaikum. Today on 23rd June 2021, I'm starting lecture number 1 for week number 13, and the topic of today's lecture is binomial distribution. So what is binomial distribution? What happens that sometimes we perform a statistical experiment where there are only two possibilities. One is known as the success and the other is known as the failure. For example, if we throw a die, then there are 6 possible outcomes. But if we are interested in occurrence of a 6, then probability that a 6 will occur will be the probability of success, while the probability that a number other than 6 will occur will be considered as probability of failure. So for application of binomial distribution, we are interested in such statistical experiments where no matter how many outcomes are there for the statistical experiment, but all possible outcomes must be categorized in either of the two possibilities, that either they should be considered as success or the outcomes should be considered as failure. So the basic requirements for application of binomial distribution is that the probabilities of success and failure are independent from each other, and the events are Bernoulli data, that every outcome could be classified in only two possibilities, either a success or a failure. Okay, so now they are giving you the example that whenever there is a binomial distribution, what happens that you repeat a trial, you repeat an experiment again and again. And how many times you repeat a trial, this is known as the number of trials, or small m. For example, if you toss a coin 15 times, then the number of trials are 15. That is then equals to 15. Similarly, if you toss the coin 20 times, obviously the number of trials become 20. Similarly, if a doctor checks a patient, this is an experiment, and if he or she checks 20 patients, then this trial of checking a patient is repeated 20 times. So we can say that the number of trials are 20. Similarly, if you are performing a statistical survey and you basically forward the survey forms to 1,000 people, so we can say that the process or the experiment of filling a survey form was repeated 1,000 times. So we can say that the number of trials are 1,000. So one of the requirements of binomial distribution is that you perform an experiment again and how many times you repeat the experiment, this is known as the number of trials, and it is represented by small n. Okay, so what is the second requirement of binomial distribution? All possible outcomes may be classified either a success or as a failure. For example, if you toss a coin, you are interested in occurrence of head, then this occurrence of head is the success, while the occurrence of tail is a failure. Similarly, if you are a quality inspector, quality control inspector, and you are basically performing quality checks, then you could either declare an item defective or you could either declare an item non-defective. So in this experiment, again, it is a Bernoulli experiment, and we can apply the binomial distribution because every possible outcomes may be categorized in either a success or a failure. So the probability of success would be represented by or denoted by small p, while probability of failure would be calculated with 1 minus p, and it could be represented or denoted by small q. Now, another requirement for application of binomial distribution is that probability of success or probability of failure, both must be constant. Since the events or the experiments are independent, therefore, no matter how many times the experiment is repeated, the probability of success or failure remains the same. For example, if you toss a coin, then probability of head is 1 over 2, and no matter how many times you toss the coin, every time the probability of head remains the same, that is 1 over 2. Uh, Now coming to the first example, if you are tossing a coin 5 times, what is the probability that you flip exactly 3 heads in 5 coin tosses? So whenever we are to solve a problem that is involving binomial distribution, we need to identify 4 different parameters. Number 1, the number of tries. So in this example, they are saying that coin is tossed 5 times. So the experiment of tossing a coin is repeated 5 times. So what we can say, that small n, that is number of tries, is equals to 5. Similarly, we want that exactly 3 heads should come. So this means that number of successes are 3. Number of successes could be represented by small x. So we could say that small x is equals to 3. Similarly, if we toss a coin, then probability of success that a head will occur is basically 1 upon 2. So small p, that is probability of head, is 1 over 2, and similarly small q, that is probability of failure, is 1 minus p, that is 1 minus half, that is equals to half as well. So in this example, we identified that number of trials that is n is equals to 5. Number of successes that is represented by small x is equals to 3. Probability of success is 1 by 2, and probability of failure is also 1 by 2 as well. Okay, so now if we find out how many different ways 3 heads could occur in a toss of 5 coins, so this is one possibility. All 3 heads in the first 3 tosses, and for the remaining 2 tosses, tails are occurring. But obviously, if we want to calculate the probability of this arrangement, so we can say 1 by 2 power 3, that is the probability of 3 heads, multiply by 1 by 2 power 2, that is probability of 2 tails. But number of 3 heads could also occur in this manner, where the first toss and the last toss has an outcome of tail, while the central 3 tosses result in a head. So if we calculate probability for this situation, then it is again 1 by 2 power 3, that is there are 3 heads occurring, and 1 by 2 power 2, that is there are 2 tails that are occurring. So in this way, what we can do, we can identify 10 different arrangements where for a toss of for 5 tosses, there are 3 number of heads and 2 number of tails. But if we apply binomial distribution, or the formula for binomial distribution here, what we could say? We could say probability of capital X equals to 3 equals to NCX p power x into q power n minus x, where obviously p is 1 by 2 and n is 5. So we can say that NCX, that is F5C3, times p power x, that is 1 by 2 power 3, into q power n minus x, that is 1 by 2 power 5 minus 3, that is 2. So hence we can calculate the total probability of all these 10 different situations. So the conclusion is that binomial distribution makes calculation simpler for you. This distribution makes calculation easier for you, regardless how many different outcomes are there. We can always apply this binomial distribution formula, regardless if n is, say, beyond 100, we can still use this formula. Okay, so if we apply binomial distribution for this question, that is for 5 tosses and 3 heads, we can simply write 5C3 into 1 by 2 power 3 into 1 by 2 power 2, and we can simply identify that the probability of 3 heads out of 5 tosses is 0.3125 or 31.25%. Now, for 5 tosses, there could be a possibility that there will not be any head out of the 5 tosses. So we can compute the probability of x equals to 0 using the formula. Similarly, for probability of x equals to 1, 2, 4, and 5, we can calculate the probabilities. And if we draw the probability distribution diagram for this problem, then it would be just like represented in this slide, where there is a possibility that out of the 5 tosses, there are no number of heads, and similarly, there is a chance that out of 5 tosses, all result in a head. So if we draw this probability distribution diagram, so we can well imagine and we can compare it with the bell-shaped curve of normal distribution, and we can see that it is quite similar to the bell-shaped curve of normal distribution. Now coming to the second example related to binomial distribution. Here the question is that in a presidential election in USA, 6 voters are interviewed and they are asked that whether they will vote for Mrs. Clinton or not. So now they are interested that what is the probability that out of the 6 voters, exactly 2 voters had cast vote for Mrs. Clinton. So in this example, now if we identify the 4 parameters, so interviewing a voter is the experiment, and this experiment is repeated 6 times. So we can say that number of trials that are equals to that could be represented by n. So number of trials are 6, so n equals to 6, and similarly probability of success is given 55.1%, that is 0.551, and we can calculate the probability of failure by simply subtracting this probability 0.551 from 1. So 1 minus 0.551, 0.449 is the probability of failure. And since we are interested in exactly 2 voters to be casting vote for Mrs. Clinton, so we can say that small x, that is number of successes, are 2. So now if we want to calculate probability for this experiment, then if we go for one by one identification for different possibilities, then it could happen that the first 2 voters casted vote for Mrs. Clinton, while the rest of the 4 voters have not. Similarly, one option is that after the first voter, the 2 voters have casted vote for Mrs. Clinton, while the rest of them had not voted for Mrs. Clinton. Similarly, so if we keep finding different possibilities, so there are a lot of possibilities where out of the 6 voters, only 2 have voted for Mrs. Clinton. So you can see that in this situation, it becomes a very difficult problem, because you have to identify that how many different possibilities or how many different arrangements are there. But if you apply the binomial distribution, you can say that out of the 6 voters, since only 2 has voted Mrs. Clinton, so we can write 6C2. So if we write 6C2, so it tells you that there are 15 different outcomes. So we don't have to identify all outcomes. Rather, what we can write, 6C2 into p power x into q power n minus x. That is, 6C2 is 15. P is basically probability of success, so 0.551. Power, since we want 2 voters to cast Mrs. Clinton, so it is x is 2. So 15 multiplied by p power 2 multiplied by q power n minus 2. So 6 minus 2 is 4. Hence, we identified that the probability that out of 6 voters, 2 votes will be given or polled to Mrs. Clinton is basically 15 into 0.551 power 2 into 0.449 power 4. So this is the probability of capital X equals to 2. What we can say? We can write it as probability of capital X equals to 2 equals to 6C2 multiplied by P power 2 into Q power n minus 2. Okay. Now, so this is the formula for binomial distribution, where on the left of this formula, one must write probability of capital X equals to small x. So it is the probability of capital X equals to small x, which is known as the binomial probability. And it could be calculated easily using the formula NCX, P power x into 1 minus P or Q power n minus x, where n is the number of tries, x is the number of successes, P is the probability of success, while Q is the probability of failure. 1 minus P is Q and Q is the probability of failure. So this is the formula that we will use for calculating probabilities of binomial distribution. And you can see that it is not a difficult formula. All you have to do is to identify 4 parameters that in a given experiment or in a given problem, what is the number of tries? What is n? Like in the previous example, 6 voters are being interviewed. So we can say that n, that is number of trials, is equal to 6. Similarly, out of the 6 voters, we want 2 voters to cast vote in favor of Mrs. Clinton. So x, that is number of successes, are basically equals to 2. And probability of success was given in the question statement. It was 0.551, and we calculated the probability of failure simply by subtracting probability of success from 1. So it is a very simple procedure. All you have to do is to identify 4 parameters, namely n, x, p, and q, and then you can use the formula to calculate the corresponding probability for a particular problem. Okay. So what is the summary? That you need to identify n, you need to find out the probability of success, you need to find out the probability of failure, and you need to know that what are the number of successes required in a particular example. Now coming to the standard notation of binomial distribution. Here you can see a symbol right after the capital X, which is written in bold. This symbol is basically read as X follows binomial distribution with number of trials equals to n and probability of success equals to p. So what is happening? That whenever they will give you a binomial distribution or a question related to binomial distribution, what they will do, they will give you this type of standard notation. And what is the meaning of this standard notation? The meaning is very simple. X follows a binomial distribution with number of trials equals to n and probability of success equals to p. Okay. So for number of successes equals to r, what could be written? Probability of x equals to r equals to NCR p power r into q power n minus r. In your textbook, that is Walpole and Myers, number of successes is represented by small x rather than small r. So if you want to change this formula in terms of x, so you should replace every r with small x. So the formula will become probability of capital X equals to small x is given by NC small x p power small x into 1 minus p power n minus small x. So this is standard formula for binomial distribution. Now coming to one more question. They are saying that if a coin is tossed 20 times, what is the probability of getting exactly 10 heads? So for exactly 10 heads, we need to find out probability of capital X equals to 10. Why? Because number of trials is basically represented by n, it is 20, while for a coin probability of success is 1 by 2, while probability of failure is 1 minus half, that is 1 by 2 as well. Now for probability of capital X equals to 10, we will write 20C10 p power 10 into q power 20 minus 10, that is 10 as well. So very simple, we can easily compute this probability. using the binomial formula, probability of capital X equals to 10 is given by 20C10 p power x into q power n minus x. Since x is 10, so 0.5 power 10 into q power 20 minus 10, that is again 0.5 power 10, and hence we got the probability, that is this 0.176. So you saw that in this example as well, we easily calculated the probability for capital X equals to 10, and we identified the four variables, that number of trials, that is n is equals to 20, small x is equals to 10, probability of success for tossing a coin is obviously 0.5, and probability of failure is 0.5 as well. Okay. Now, if a coin is tossed 20 times and we are interested in calculating the probability of getting a 2 or fewer than 2, so it means that we are interested in occurrence of 0 heads, 1 heads, and 2 heads. Sorry, 0 heads, 1 heads. So what we will do, 0 heads, 1 head, and 2 heads. So what we will do, we will use the formula 3 times, because we need to calculate the probability of 2 or fewer than 2. So we will use the formula 3 times. For first time, we will use 20C0. For second time, we will use 20C1. And for the last time, we will use 20C2. So you can see that for 0 number of heads, we have written 20C0, 0.5 power x, that is 0, and 1 minus 0.5 power n minus x. Similarly, for number of heads equals to 1, we will write 20C1 into 0.5 power 1 into 0.5 power 19. And similarly, for 2 heads, we will write 20C2 p power 2 into q power n minus 2. And hence, we will add up or sum up all these probabilities and we'll get the final result. Okay. How to calculate the expected value? Okay, how to calculate the mean or expected value of a standard binomial distribution? It is a very simple procedure. Recall that till now you have calculated means for ungrouped data, that was represented by summation x over n. Similarly, mean for group data, that was computed by the formula summation fx upon summation f. Similarly, mean for probability distribution table, that was computed using the formula summation x into probability of x. So now, if we are interested in calculating the mean of a binomial distribution, it is a very simple procedure. You can easily compute mean of a binomial distribution or a Bernoulli experiment using the formula n into p. So if x follows a binomial distribution with mean with number of trials equals to n and probability of success equals to 5, then mean of this binomial distribution may be represented by Greek alphabet mu x, and it is equals to expectation of x, which could be calculated or computed using the formula n into p. So all you have to do is to multiply or take the product of the number of trials and the probability of success. Similarly, if you want to calculate the variance of binomial distribution, it is also very simple. To calculate the variance, you will multiply n, p, and q, and the product of n, p, q will represent variance of the binomial distribution. And obviously, to calculate the standard deviation, what we will do, we will take the root of this variance, and hence we will get the standard deviation of binomial distribution. So you can see that all these three formulas are quite simple, and calculating the mean, variance, and standard deviation of a binomial distribution is very simple. All you need to know is the number of trials, that is n, and the probability of success, that is p, and you can compute all these three parameters. So regarding the variance, what we can say, usually it is in between 0 to 0.25, and Particularly, the maximum value of variance is 0.25 when the probability of success is 0.5. So now if we are interested in calculating a probability where the number of trials are equals to 500 and the probability of success is given as 0.05, the question is how many do you expect to develop the disease? What is happening? You are performing a cohort study. If the probability of developing a disease in the exposed group is 0.05 for the study duration, then if you sample randomly 500 exposed people, how many do you expect to develop the disease? Now this wording is very critical. They are saying how many do you expect? Basically this expect is from expectation, and expectation means mean. So when they ask how do you expect, what we need to calculate is the mean of the distribution. So what we will do, we will calculate the mean of this binomial distribution. We were given that n is 500, probability of success is 0.05. So we will multiply n into p, and hence we will get the expectation of this distribution. Now they are saying that give a margin of plus minus 1 standard deviation. So we will compute the mean, and then we will compute the variance and standard deviation. Then we will add or subtract 1 standard deviation from the mean value to get the required margin. So first of all, let me just show the calculation for this first part. So for calculating the expectation or mean of random variable, what we did, we multiplied 500 with 0.05. We multiplied 500 with 0.05, and hence we got expectation of x equals to 25. Similarly, to calculate the variance of this binomial distribution, what we did, we computed p into n into p into q, and then we took the root of or the square root of this calculation to get the value of standard deviation. Now to calculate or to offer margin of 1 standard deviation, what we will do, we will add or subtract this 4.87 with the mean value. So we wrote 25 plus minus 4.87 to offer a margin of 1 standard deviation from its mean value. You know that standard deviation is a measure of spread. It is a measure that how a random variable is distributed from its mean value. So to offer a margin of 1 standard deviation, what we will do, either we will add 1 standard deviation in the mean value, or we will subtract 1 standard deviation from the mean value. So this is the margin of 1 standard deviation. Now coming to the next question or second part of this problem. They are saying that what is the probability that at most 10 exposed subjects develop the disease? Now this is a question which requires the application of binomial formula 11 times. So now to apply this formula 11 times is not an easy task. It is a time consuming task as well, and one could do a mistake while applying the formula 11 times. So according to the question, if we need to calculate probability of at most 10, it means we need to calculate probability of x less than equals to 10, that is probability of x equals to 0, 1, 2, 3, 4, 5 till 10. So we need to apply the formula 11 times, sorry. But there is a way where we can avoid this 11 calculations of the binomial distribution formula. And what is it? They have given you a very small hint that later you will learn how to approximate this long sum in a jiffy. Actually, what happens under certain clauses, under certain restrictions, under certain limitations, binomial distribution could be converted into a standard normal distribution. And after the conversion of binomial distribution into standard normal distribution, what we can do, we can simply use the table for standard normal distribution to compute this sum. So therefore, they gave you a hint that if n is beyond a certain limitation, then according to a given criteria, we can convert this binomial distribution into a standard normal distribution, and then we can make use of the table of standard normal distribution to have to calculate this large sum or this long sum. Okay, so now coming to the Pascal triangle. What is Pascal triangle? You have learned in your FSC or in your high school that you can find out the coefficients of binomial distribution using a triangle formula, which is known as the Pascal triangle. What we do, actually, we make a triangular figure where for a plus b whole power 1, we have the coefficient 1 for a and 1 for b. Similarly, for a plus b whole power 2, what we do, we add 1 and 1, we get a 2. We write 2, 1 on both sides of 2, and hence we got the three coefficients of a plus b whole square, that is a square plus 2ab plus b square. So the first term is having a coefficient of 1, the second term is having a coefficient of 2, and the third term and the last term is having a coefficient of 1 again. Similarly, if you want to calculate formula for a plus b whole power 4, all you need to know is the coefficients. So what you will do, you will add 1 and 2, you will get a result of 3. Then you will add 2 and 1, you will get a result of 3. And then you will again take 2 ones, 1 on the left side of 3 and 1 1 on the right side of the 3, and hence you will get the 4 coefficients 1 3 3 and 1. That are basically the coefficients of a plus b whole power 4. So this triangle can be expanded so on and so forth for any value of n. So this is one way to calculate probabilities of binomial distribution by finding the corresponding coefficients without use of calculator. But since you are in your graduate studies, so you are fully authorized or allowed to use calculators, so you don't need to apply this triangular way for finding the coefficients of binomial expansion. But if you want to use this binomial expansion, I won't mind, and it is allowed. So this is basically the procedure for finding the coefficients of a binomial expansion. Now coming to another question, they are saying that the problem where we basically toss the coin 5 times and probability of success was 0.5. So we can compute or we can basically construct this probability distribution table either by using the formula or by using the Pascal triangle for finding the coefficients and then multiplying with the probabilities 0.5 power 0 and 0.5 power 5, etc. So in any case, you can construct this probability distribution table for the binomial distribution of the given question. So that was it. So that was all from my side today. Inshallah, in the next lecture, we will cover normal approximation to binomial distribution. And so in the next lecture, we will cover normal approximation of binomial distribution, and where I shall share with you the procedure by virtue of which we can convert a binomial distribution into a standard normal distribution under a certain allowed criteria, under a certain clause. If this clause is fulfilled, or it basically if this clause is present there, only then we can convert a binomial distribution into a standard normal distribution. And what is that clause? Actually, if n is quite big, say it is 500 and p is say 0.25, then what we will do, we will calculate np. And if it is more than 5, then we will calculate nq. And if it is also more than 5, then we will say that since np and nq both are more than 5, then the binomial distribution could be converted into a standard normal distribution. So inshallah, we will discuss this conversion of or this approximation of binomial distribution into normal distribution in the next lecture. So till then, take care and Allah Hafiz. And if you want to ask any question, you can ask it right now. Okay, no questions? Okay, so inshallah, we'll see you in the next class. Till then, take care and Allah Hafiz.
Allah Hafiz.